Anybody who's joining the show a little bit early, we are going to be starting in about 3 or 4 minutes' time. And we're going to be starting the show in a couple of minutes' time. And although you just heard my clock there, I'm just waiting for our producer to screen share in my particular feed, and then we'll get the show underway. Are you there, Bob?
I am.
You are. I'm not sure if Pat can actually hear me. I don't think he's screen shared in my thing. My particular Hangout, he hasn't made that big. But anyway, we will start the show nevertheless. Hello, everybody. Welcome and good evening or good afternoon, depending upon where you are, to the Slooh Space Camera. And we've got some great live coverage tonight. Don't be too alarmed, we're not actually going to show you this asteroid or whatever it was that's slamming into the moon or slammed into the moon on the 17th of March. But we're going to talk about the implications of, this kind of thing and some other activity as well that we've been seeing recently. I'm just going to show you another video. So hopefully this has been screen shared in to the Hangout. It hasn't. Mr. Palucci, our producer, could you please make my screen share the large box in the Hangout, please? And he says he is. Right, well, hopefully you can see this large. I can't, but anyway. This is the actual video. This is the video, the NASA footage of this asteroid. It wasn't very big. I mean, it's an object, really, Bob, I think we're going to be talking about. But you see that little instantaneous flash. And tonight, we're going to be talking about the implications of that. And I just want to show you very quickly on the homepage, because while our esteemed guest, Mr. Bob Berman, astronomy author extraordinaire, is talking to us about this event, you can see some fantastic live images of the moon. So here you go. Here is the homepage, and you can see here this is what we call our T2 high mag telescope view, which is giving us, it is cloudy tonight, folks, so the images aren't quite as sharp as they usually are, but we've got the T2 high mag telescope view where you can really start seeing some detail. We've also got some fantastic full lunar disk images from the half-meter telescope. Those images are stunning. I think the clouds must have fallen away to give us an image that good.
They look beautiful, beautiful.
They do, absolutely stunning. And then our all-sky camera will tell us, will show us the kind of weather that we're dealing with tonight. But there you see it. It looks like the sun, but that's actually the moon, and it's coming through sufficiently through these clouds to show us these magnificent live images. Now, if you've got a Pinterest account, you can click the pin it button and the current image will go straight to your Pinterest board. Or if you want one of these images, you can use the new Slooh iPad app, which is a virtual sky. It's a free app, but you can order a mission, book a mission to the moon, Saturn, any kind of galaxy, all sorts of fantastic objects. And the Slooh telescopes, the ones that we're using tonight, will automatically slew into position, take an image for you, and it'll be uploaded directly into your app. So now sales inside the app for missions, they do help us to put on these live shows, so we really appreciate your support, but you should download that app because it's pretty cool in any case. Anyway, without further ado, I am going to introduce our esteemed guest this evening, Mr. Bob Berman. Hello, Bob. How are you?
Oh, I'm great. Great here in upstate New York in the dark mountains here with thunderstorms around. But I'm looking at this beautiful view, especially the one of the half-meter telescope, and this is showing it. Really, you can pinpoint all of our viewers simply by pressing on those bluish-green triangles. Can go to the half-meter telescope view, which is showing you the entire moon. That's what we're talking about live. And you can find the spot that this impact occurred in Mare Imbrium. It's very easy to find.
Hey, Bob, I've got a graphic which will show people very, very clearly. This is an image from the half-meter telescope 2 nights ago, and hopefully you can see this shared into the Hangout, and you can see it's roughly the same kind of view that we've got tonight, and you can see here. So, Bob, I don't know if you want to explain and help people navigate around this, but hopefully people can see this big yellow circle I've drawn, and that's where this object smashed into the moon.
Yes, I can see that there. I don't see that in the Slooh app.
No, it's not on the home page. Bob, this is just one that I'm screen sharing in.
I see. Well, in any case, if you are looking at the using our home page, and go to the exact center of the moon, and you'll see just to the left of the center there's a very bright crater with kind of rays or streaks coming out of it. That's the famous Copernicus, and just to the upper left of that is the place in Mare Imbrium that got hit. Now the mares are the areas that we used to think, we being in the 17th century, used to think were oceans or seas. Those are the prominent dark areas on the moon. Of course, people remember the Sea of Tranquility because that's where the first astronauts landed. And in 1969, July 20th of that year. But if you look at the dark blotches on the moon, those are all areas of solidified lava, and that in one of them is what took this impact on March 17th. The double blotches on the upper right of the moon, if you go from the center, just sort of the 1 o'clock or 2 o'clock position, you get to the Sea of Serenity and the Sea of Tranquility. Very odd that their naming system, they're all named for either emotions or weather phenomena. Now, how did that happen? In other words, we have a Sea of Tranquility, we have a Sea of Serenity, we have a Sea of Crises. You know, if you have a crisis, that's an emotional thing, serenity, tranquility. But you also have an ocean of storms. You have a sea of rains. So it's either going to be weather or emotions, and usually we use the Latin names for all of them. And this impact occurred just to the upper left of the famous Copernicus, that very bright crater to the left of center. Very prominent crater, about 54 miles across, 80 kilometers across, with walled terraces that step down into it. And I love this Slooh live view of that region right now. The moon is a gibbous moon. Gibbous meaning protruding or fat in. It's the phase that people are least familiar with. Everyone knows what a crescent moon is, a half moon is, a full moon, but the gibbous seems to elude a lot of people. But that's what we're looking at tonight, the gibbous moon.
Tell us more about the actual impact and who spotted it, how it was spotted, what it means for us. I mean, why is it really important?
It's very special. There's been a program going on for about 8 years looking for impacts on the moon, and this is the largest that's ever been seen. Now, what makes this special is not that a 1 foot boulder, 1 foot is a rock you could pick up here on Earth. It probably weighed about 80 pounds. Anyone could, well, I can't say anyone could pick it up. A child couldn't pick up an 80-pound boulder. We're talking about an 80-pound boulder going probably 56,000 miles an hour. So, bam, that's going to make a flash of light, even if there's no oxygen. And to see something as bright as 4th magnitude, that's not a bright star, but it's visible. A naked eye object hitting the moon, maybe creating a crater as much as 60 feet wide, but that's not the real news. The real news is that on that same date of March 17th, Earth was hit by a series of fireballs, meteors, bright meteors that all traveled in the same parallel direction as this thing that hit the moon, which tells us that there was some kind of short duration impact series. There was a swarm of meteoroids that were sweeping across our orbit, and therefore the moon too, because the moon keeps us company in space, that we went through, or we could say that it went through our orbit and hit us and hit the moon on the same date. And so, wow, now we're looking forward to next March 17th, because we return to the same place in our orbit on the same date, next March 17th, to see if that happens again. In other words, is this sort of an unknown meteor shower? Because that's what meteor showers are when Earth intercepts a swarm of debris, usually comet debris. But even if it's asteroid debris, the meteor shower every December 13th, the Geminids, that may be an asteroid named Phaethon that has produced that. Whatever it was, here is a swarm of material, and of course we're interested in things that hit us. We've had our biosphere change. We've had the dinosaurs famously wiped out. And to be able to image this is why it's very cool. So people who are on the app can book a mission to the moon. That means you can order the telescope to point there and look at that spot that we're looking at on this historic occasion, really. But it's historic because this is the first time that I can recall, I don't know about you, Paul, where we've known the Earth and the Moon to both be hit at the same time, same date, same time, by a swarm of debris. That's pretty amazing.
It is, and I think one of the interesting things that I find about this whole event, really, Bob, is that, this NASA program's been up and running since, 2005, 2006, something like that. And, even up to a few years ago, amateur astronomers had been reporting seeing flashes on the moon as they were observing the moon. And their reports were treated with quite a lot of derision from professional astronomers and the media and just about everybody generally. Now, unbeknown to a lot of people, NASA started this project up. And they've got 4 telescopes at 3 observatory sites now trained on the dark part of the moon, because obviously you can't see these if they hit the sunlit part of the moon. And suddenly, before they knew it, they were recording these flashes left, right, and center. And I think so far that NASA program since 2006 has found something like 300 or so of these large flashes, half of which are associated to known meteor storms. So those kind of were expected, if you like, because they were occurring at the same time. But half of these things are either what we call sporadic meteorites. Bob, you might want to tell us what those are in a second. But also, one of the main purposes of this NASA program is to identify previously unknown debris trails. So we're looking at Comet Ison hurtling through our solar system at the moment. We've been seeing near-Earth asteroids nearly missing Earth, and we've got a big one coming up at the end of the month. Now, some of these things, Bob, they leave these trails of debris, don't they? And that's what the Earth then passes through.
Exactly, exactly. And any night, any clear night, especially after midnight, any observer can see an average of 6 meteors per hour. And during a meteor shower, more than that, as much as 60 or 90 or even 100 meteors an hour. And this is debris. This is bits of comets. Most of them are small, the size of raisins or even apple seeds that are
Hey,
the
Bob,
typical. Yes.
there's a fantastic, interesting fact. Even though they're that size, every single day there's 33 metric tons that hit the Earth's atmosphere. Every single day. That's
And it rains down as
pounds. Yeah.
That's right, making Earth heavier all the time. It's not just us as individuals that are gaining weight.
Yeah.
It's the entire planet.
There's an important aspect there, isn't there? That a lot of that dust and material burns up in the atmosphere, but the moon doesn't have that same atmosphere. So that's why this particular object, only a few feet across, landed up having, I think they said it was the energy of 5 kilotons, or no, 5 tons of TNT, because it slammed into the moon at something like 55,000 miles per hour, because there was nothing there to stop it. Would an object that size, Bob, would it make it to Earth if it came through the Earth's atmosphere? So it wouldn't make it through. Okay.
No, the cutoff is about 100,000, believe it or not, thankfully, 100,000 tons. At 100,000 tons or more, an object is going to hit Earth at full cosmic velocity, just as this object did. There's no atmosphere, as you said, so anything will hit the moon at its cosmic velocity. Its speed plus the moon's, if they're moving toward each other. On Earth, thanks to the atmosphere, it'll be slowed down if it weighs less than 100,000 tons. If it to a terminal velocity, which is typical of only 250 miles an hour. Your typical meteor that goes through the roof of the house only hits the roof at 250 miles an hour. That's average. So it slows down from its initial speed, which is typically 20 miles a second, or almost 70,000 miles an hour, not very different from this one, down to just 250 miles an hour. And it turns out that that speed is just enough to fully penetrate the roof and usually penetrate one more floor, in other words, your attic, and then end up in the second story of a person's house. That's what we've seen over and over.
So you're pretty unlucky if you live in a bungalow then. A bungalow is a single-story house, is what we call a single-story house. Bob, there's a question that's come in, and actually it's very similar to, by the way, anybody on the homepage, just press the Slooh Conversations box here, and you can get a question straight through to Bob or I. We can tell you about the equipment that we're using, how to use Slooh, how to use the iPad app, and all about this event. It's very similar, this question, to one that we had on our special Comet ISON show. Somebody asked for the Comet ISON show, can ISON pull Mars out of its orbit? And this particular question is, can the impact that occurred on the moon on March 17th, can that affect the moon's orbit in any way?
Well, that would be like asking, can a flea, if a cement truck barreling down the highway hits a little gnat that's flying onto the windshield, will it knock the cement truck off
I think it's fair to say that the gnat comes off worst in that exchange, doesn't it?
Yes, and even that would be an exaggeration, because the comparison of the mass between this object only a foot across and the moon, which is 2,160 miles across, would be more of a inequality than the cement truck and the gnat, the flying gnat. So no, okay. One is not going to budge.
Yeah, I mean, we do get a lot of similar questions on a lot of the events when we see near-Earth asteroids and things like that. You know, the Earth, the Moon, the other planets are such massive bodies that really it takes another body of that kind of size, doesn't it, Bob, to start perturbing orbits and affecting the other planets around them, doesn't it?
Yes, and it does, but eventually it does. For example, it's now calculated that Mercury, which already has the most eccentric of all the orbits of the remaining 8 planets, now that poor Pluto has been demoted, will be so perturbed by Jupiter, of all unlikely villains.
Yeah.
Jupiter, which is so far away, nonetheless ultimately affects Mercury's orbit, changes it from a rounder orbit to a more eccentric ellipse, so that it's very possible that it'll be so eccentric that it'll extend all the way to the orbit of Venus. Poor Venus is innocent. Venus has the roundest orbit of every planet. Its eccentricity, I know you know what this means, is 0.007. It's almost perfectly round, and yet Mercury and Venus may collide in the next 5 billion years, so it's safe for the moment, thanks to the influence from Jupiter. So yes, these planets definitely influence each other, but not these little tiny objects.
Okay. Now, Bob, I'm screen sharing into the Hangout, and don't forget, folks, we normally say that the best place to watch these shows is at slooh.com. We don't say that just because we want people landing on slooh.com, but that's where, and I'll pop back to that for a second, that's where you can switch between the different telescope views. These telescopes, that's the all-sky camera from our Canary Islands Observatory. That's off the west coast of Africa. It's at 8,000 feet. It's usually above the clouds. It's so high, and we don't look through very much atmosphere, and that's why it's a world-class observatory site, and that's where the Slooh telescopes are based. We've got 2 telescopes for you tonight. We've got our T2 high mag telescope view, which is the one here. Now, we are looking through clouds, so it is a little bit blurry there, but we're also looking through our half-meter telescope view here, and that always gives such a stunning view. And I'll tell you, you have to, please, if you don't do anything else, if you have an iPad, download our app and order a lunar mission. This is one of the images, all right, that went off to somebody who ordered a lunar mission the other day. Look at this. Fantastic detail. This is the edge of the moon, and we're seeing the ridges and mountains and valleys. It's just absolutely stunning. And one of the things that I recommend people to do is to collect lunar phases in the app. So when you're inside the app, you see all of your images of the moon, and you can flick through and see the phases of the moon changing. It's really, really cool. But anyway, you can control those same telescopes that we're using tonight. As a Slooh member, you can join up, you can see the membership button on the homepage, you can sign up, and you get to control the telescopes directly when you want, where you want. And then with the app, it's really, really simple. You literally just have to click on an object, and then the Slooh machine goes into action, and it makes sure that it schedules that particular mission for you just at the right time when the object's high in the sky and looking its best. And there's some great videos in there as well that'll help guide you through that. But please consider doing that, because you can be controlling the same telescopes that we're seeing here. But I just wanted to raise one point here, Bob, because it's something that has been asked on a couple of websites. This flash, this particular impact, is the largest of the 300 odd that NASA have seen in the last 6 or 7 years, however long it's been. Sorry, 2006, slightly longer than that. Now, some skeptics have been saying, look, it's nonsense. That's NASA rubbish. It's all conspiracy. Things can't flash on the moon because it's got no oxygen. It's got no atmosphere. So how can something burn? So why do we see an object like this flash when it impacts the moon?
Well, because the difference is on Earth, indeed, it's the air that's glowing from the heat that we see when an incoming meteor crosses the sky. In fact, few people realize this. You never actually see a shooting star. You don't see the meteoroid itself. You see the glowing air, the ionized air that surrounds it, that's been heated by this little raisin-sized object, because who could see an object the size of an apple seed from a distance of 60 or 70 miles, which is how far away they are from you? Nobody could, no matter how much it's glowing. So we do see the glowing air. Not so on the moon. Here we've got another story. Instead, this kinetic energy, and there is so much of it, in other words, the energy of motion, is instantly converted on impact when it hits the moon's surface, which is more than half oxygen and about 1/4 silicon. In other words, a sandy-like substance. It has to immediately release that kinetic energy, which gets changed into what we see as light or heat. It's not so much heat. It's actually a flash of light.
I heard, Bob, that it was that the majority of that kinetic energy, and just as a reminder to everybody, Bob, kinetic energy, it's what the result of the object's mass and its velocity. Is that right?
That's right. It's mass times velocity squared. And in this case, the mass was small. We think it only weighed 80 pounds, but the velocity was 56,000 miles an hour. Now, by comparison, a high-velocity rifle bullet will typically travel half a mile a second, so you're talking about only a tiny fraction of the speed of this, much faster than a bullet. So, of course, it has to release and translate this energy.
So the majority of this energy is coming from the object speed, which we've already established. It's a hell of a lot faster than an object like this would be hitting Earth. You're saying about 250 miles per hour for an object like that hitting Earth because it's slowed down by the atmosphere. And I heard that most of that energy is dissipated in heat caused by the actual impact, and that a lot of the light that we were actually seeing was the result, or light emitted from the molten rock, or the molten substance that was then generated in that impact. So is that a fair assessment or not?
Yes, it would be fair. Yeah. We remember when we're talking about heat, we're really talking about infrared radiation, so which is still electromagnetic radiation. So, but some of it still translates into the visible part.
Visible
of the
light. Yeah.
Yes.
So when this, I think, often comes down to, this plays to our innate fears, doesn't it, about how threatened we are on Earth by these objects. Because I think over the last year or so, we've covered a number of near-Earth asteroids which have really been discovered only, in some cases, only a few days before their closest approach to Earth. We got a big one, one that was discovered in 1998. We've got one of those coming up, which we're going to be covering on a live show. But I think there has been a lot of fear-mongering about this stuff, Bob. But, you know, you don't need to fearmonger, actually, to make this a really, really important subject and a very important topic for the scientific community. And I think that's why NASA are looking at the moon all the time. They're observing the moon with these video cameras, and they've got special software that automatically alerts them if they see one of these flashes on there. So we are starting to take this a little bit more seriously, aren't we?
Yes, and we should. And we should, even though only one person was ever injured, at least only one definite case, Ann Hodges in Sylacauga, Alabama in 1954, who wasn't even badly injured, just injured on her upper thigh near her hip when a chondrite, that's a stony type of meteor, came through her roof. You know, this is again the typical scenario, through the roof, through the attic, bounced off her radio, her console radio, and hit her there. That was the only person who was injured. But,
Bob, the injury figures changed dramatically, didn't they?
They did
earlier this year.
This year.
And we covered this. We were covering, I've forgotten which asteroid it was now. It was a near-Earth asteroid that had been discovered in a very short period of time. And on that same morning, it was the Russian meteor.
Amazing. All of a sudden, we went to 1,000 injuries. Of course, none of them were injured directly by the stone. Yeah. It was more like the sonic boom that broke glass that cut these people. But fortunately,
DA-14, I'm being reminded.
And so fortunately for that, I see a question that popped up where somebody's asking if the moon protects us from devastating crashes to Earth, since the Earth magnet attracts. Well, you know, the Earth doesn't really have. First of all, the Earth's magnetic field is so weak. It's about 100 times weaker than a refrigerator magnet, and it's not going to attract anything, even though most, or at least many meteorites, certainly the octahedrites, are made of materials, nickel and iron, that will be pulled by a magnet, but Earth's magnet is not what pulls them. Their speeds and their trajectories are such that they are not going to change their trajectory because of Earth's wimpy magnetic field. So no, the moon doesn't shield us in that sense at all.
Thank you for that, Bob.
Plus, the moon weighs 81 times less than we do, so it's not going to be doing a very good job of of guiding materials away from ourselves. It just the occasional one will hit the moon instead of Earth.
But what we have said in some of our shows, Bob, when we've been looking at the comets and the asteroids that have been hurtling towards the inner solar system, and this kind of what we think of quite often as a fairly static, dull neighborhood, I think we're beginning to understand just how dynamic a place our solar system is. And last year we were doing a Jupiter show on our month of live astronomy. We did a whole series of shows. And that same night, bang, an enormous flash was seen in Jupiter's atmosphere. We still don't know if it was an asteroid or a comet that impacted Jupiter, but going back to that question, the moon doesn't protect Earth so much, but Jupiter does, doesn't it? Jupiter is a great protector of the other planets.
Yes, it's a vacuum cleaner, at least from objects coming in from the outer solar system. It's not that close to us. It's at the closest, it's 4.2 times the Earth-Sun distance. So we're talking about 400 million miles away. And at that distance, what it really does is keeps things that are farther away from sweeping inward. But the majority of asteroids, as you know, are between Mars and Jupiter anyway. They're on our side of Jupiter. So we still have plenty of the near-Earth objects that cross our path, and yes, we better keep track of them, because as we know, they have changed Earth's history in the past.
They surely have. Now, this is only one in a whole series of live free shows that we do to the public here at the Slooh Space Camera. We got another one at the weekend. We got the penumbral lunar eclipse. That'll be an interesting one, maybe not as spectacular as some of our other eclipses, but certainly still worth a look, because we're going to be seeing similar views to this, these absolutely stunning views of the moon, and these are live views. You just seen the one from the half-meter telescope just pop up. The next image has popped up. Now, just to remind you, these telescopes, Slooh's telescopes, are perched on top of an incredibly high volcano in the middle of the Atlantic Ocean. Well, actually, it's off to one side of the Atlantic Ocean, but you, anybody, can control these very same telescopes. So we're about to renew the mount shortly for the half-meter telescope, so that's going to be performing, you know, a lot better in the future. So we're looking forward to that. But you can control those telescopes either by joining Slooh. Just click the membership button. If you don't want to join Slooh, then you can also give us a donation if you enjoy our live free events for people. But if you have an iPad, and by the way, for anybody who's asking, phase 2 development of our app will be to port it out to other mobile devices as well. But if you've got an iPad at the moment, do download our free Slooh Space Camera app. It's a virtual sky, so it kind of helps you find your way around the sky. But click on any of the icons, any of the object icons in there. So tonight, I would highly recommend search for the moon, or go to the top missions, click on the moon, order one of those missions for the moon, and I personally will make sure that you get the control of one of those telescopes that will give you one of the best images of the moon you've ever seen. And it's great fun. It's really good fun collecting lunar phases and all of the other objects in our app. So please take a look at that, because it does help us provide these live events. Bob, I don't know if you've got any other words to round off this particular show. We're going to be back shortly at the weekend, and we've got some other shows coming up as well. But what have you got for tonight about this particular lunar impact that NASA reported?
Yes, well, we're going to have a show entirely for other mammals other than human beings. As you know, we're having a show for dogs coming up, because many of the constellations in the sky, Canis Major, Canis Minor, are canines. There is a wolf constellation, and so we're going to branch out from the human realm to try to appeal to other carbon-based life forms other than human beings. And the reason I'm saying this, Paul, is as I understand it, the show is now over, and so I don't think anyone is hearing this at this point. So I think we're wrapped up. We had a great show tonight with these beautiful views of the moon.
Okay, well, I think I'm not sure if the Hangout was actually continuing. Yeah, they were hearing our audio there, Bob. So always be a little bit cautious on that one, what you say. This is Paul Cox, and I've been joined by Bob Berman, astronomy author extraordinaire, on this special Slooh Space Camera show. We hope to see you back very soon. Goodbye for now.
Okay,
Good night, Bob.
goodbye.
Thank you very much.
Good night.
Anybody who's joining the show a little bit early, we are going to be starting in about 3 or 4 minutes' time. The show, nevertheless. Hello, everybody. Welcome and good evening, or good afternoon, depending upon where you are, to the Slooh Space Camera. And we've got some great live coverage tonight. Don't be too alarmed. We're not actually going to show you this asteroid or whatever it was that's slamming into the moon or slammed into the moon on the 17th of March. But we're going to talk about the implications of, this kind of thing and some other activity as well that we've been seeing recently. I'm just going to show you another video. So hopefully this has been screen shared in to the Hangout. It hasn't. Mr. Palucci, our producer, could you please make my screen share the large box in the Hangout, please? And he says he is. Right, well, hopefully you can see this large. I can't, but anyway. This is the actual video. This is the video, the NASA footage of this asteroid. It wasn't very big. I mean, it's an object, really, Bob, I think we're going to be talking about. But you see that little instantaneous flash. And tonight, we're going to be talking about the implications of that. And I just want to show you very quickly on the homepage, because while our esteemed guest, Mr. Bob Berman, astronomy author extraordinaire, is talking to us about this event, you can see some fantastic live images of the moon. So here you go. Here is the homepage, and you can see here this is what we call our T2 high mag telescope view, which is giving us, it is cloudy tonight, folks, so the images aren't quite as sharp as they usually are, but we've got the T2 high mag telescope view where you can really start seeing some detail. We've also got some fantastic full lunar disk images from the half-meter telescope. Those images are stunning. I think the clouds must have fallen away to give us an image that good.
They look beautiful, beautiful.
They do, absolutely stunning. And then our all-sky camera will tell us, will show us the kind of weather that we're dealing with tonight. But there you see it. It looks like the sun, but that's actually the moon, and it's coming through sufficiently through these clouds to show us these magnificent. And although you just heard my clock there, I'm just waiting for our producer to screen share in my particular feed, and then we'll get the show underway. Are you there, Bob?
I am.
You are. I'm not sure if Pat can actually hear me. I don't think he's screen shared in my thing. My particular Hangout, he hasn't made that big. But anyway, we will start. And we're going to be starting the show in a couple of minutes' time.